Welcome to aminacademy.com. In sequence and series, let us discuss about E is an irrational number. We prove the result E is an irrational number by using method of contradiction. Method of contradiction. Let E is an rational number. Is an that is equal P over Q, where P and Q are positive integers. Where P and Q are positive integers. Now we know that E, the expansion, equal P over Q, that is equal 1 plus 1 over 1 factorial plus 1 over 2 factorial plus 1 over 3 factorial plus dot dot plus 1 over Q factorial plus 1 over Q plus 1 factorial plus dot dot dot. This, let it be 1. Now multiply 1 into P over Q. Now multiply by 1 into Q factorial, will get Q factorial into P over Q, that is equal Q factorial into 1 plus 1 over 1 factorial plus 1 over 2 factorial plus 1 over 3 factorial plus 1 over Q factorial plus, after that, plus dot 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 plus 1 over Q factorial plus 1 over Q plus 1 factorial and plus dot dot dot. Or here Q factorial can be expressed Q into Q minus 1 factorial into P over Q, that is equal P into Q factorial can be written as Q, that is Q minus 1 the factorial. Because Q factorial can be expressed as Q into Q minus 1 factorial. Then this is equal Q factorial into 1 plus 1 over 1 factorial is 1 plus 1 over 2 factorial plus dot 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 1 over Q factorial plus Q factorial into 1 over Q plus, Q factorial can be expressed Q plus 1 factorial plus 1 over Q plus 2 factorial plus dot 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 infinity. Now, which is equal, here q factorial into 1 plus 1 over 1 over q factorial plus 1 over q factorial is an integer. If you multiply throughout, it becomes q factorial into 1 plus 1 plus 1 over q factorial up to q factorial. The q factorial will cut, the rest of the things becomes an integer. Plus the second expression, here q factorial into 1 over q plus 1 factorial is 1 over q plus 1 plus 1 over here 1 over q plus 1 into q plus 2 plus dot 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 plus infinity terms. Now we know that 1 over q plus 1 into q plus 2 is lesser than 1 over q plus 1 the square, because q plus 1 into q plus 2 we can written as which is greater than 1 over q plus 1 and q plus 2, that is we get square. And similarly you can write 1 over q plus 1 q plus 2 is lesser than, here one more factor, that is q plus 3, which is lesser than 1 over q plus 1 q, and so on. Now therefore we can express this as 1 over q plus 1 plus 1 over q plus 1 into q plus 2 plus 1 over q plus 1 into q plus 2 into q plus 3 plus dot 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 up to infinity terms. Now which is lesser than 1 over q plus 1 plus 1 over q plus 1 the square plus 1 over q plus 1 q plus dot 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 up to infinity terms. Now here also you can see it is equal to 1 over q plus 1 plus 1 over q plus 1 into q plus 2 plus dot 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 plus infinity terms plus sum of infinity terms of 1 over q plus 1 plus 1 over q plus 1 square plus 1 over q plus 1 cube sum to infinity, which gives the result is 1 over q. Means the 1 over q is the sum of infinity up to that series is 1 over q plus 1 plus 1 over q plus 2 square, q plus 1 square plus 1 over q plus 1 cube, like that. Now Here this, therefore we can write this as, here this up to infinity term gives 1 over q. Therefore this 1 over q plus 1 plus 1 over q plus 1 into q plus 2 up to infinity terms is greater than 1 over q plus 1. This is 3, and this 1 over q is a little bit from 1 and 2. From 2 and 3, it follows that 1 over q plus 1 plus 1 over q plus 1 into q plus 2 plus dot 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 up to infinity term lies between lies between 1 over q plus 1 and 1 over q. It shows that the value is a proper fraction. Therefore we conclude that RHS term of 1 is the sum of integer and proper fraction, which gives sum of integer plus proper fraction sum of integer plus proper fraction here. This gives sum of integer and proper fraction, but before we equate that is proper fraction. Here you can say positive integer cannot be equal to a fraction, cannot be equal to a fraction. This gives contradiction. This gives contradiction. Therefore our supposition is wrong. This gives contradiction. Therefore we can conclude is an irrational. Is an irrational number. We have done. Please subscribe our YouTube channel.